Best wishes to all participants of the conference. To your attention, the results of the research work, technology of forming a wear-resistant thermite layers based on the ferrum-chromium-carbon system by self-propagating high-temperature synthesis. It is known that it is optimal to pure molten metal in T-mold with a temperature close to the crystallization temperature. But even so, it is not possible to obtain two-layer bimetallic castings due to the lack of the quality zone for the formation of functional layers. That is why the use of self-propagating high-temperature synthesis to form a wear-resistant layer of thermite alloy on a metal basis can be a cost-effective alternative for the production of bimetallic products. The essay of determining the optimal technological parameters of the forming a wear-resistant layer of thermite alloy based on the ferrum-chromium-carbon system has not been given sufficient attention. This area of research is quite relevant. When considering the technology, next materials were used of these components of the charge. To study the process of thermite alloy surfacing on a metal base was carried out in a mold consisting of the sand clay shell with the lid. To study the kinetics of the thermal process occurring in the mold during the formation of a layer, an experimental laboratory setup was additionally developed. In reality, to accelerate the heating time of the mold with correct contact to open surface with the heated atmosphere of the surface, a mold with an open metal base in the lower part was made. The base, lower part, open space. The use of this design has reduced the heating time of the mold from 220 up to 90 minutes. However, it should be noted that it makes significant changes in the course of self-propagating high-temperature synthesis. After initiating the combustion of the thermite charge for 0.5 minutes from the beginning of the process, there is a sharp decrease in the temperature of the lower surface of the metal base. Analysis of thermocouples installed on the upper surface of the metal base, curve 2, showed that the total combustion time of the thermite chain is 805 seconds, where the combustion from reaches the surface of the metal base and the temperature for 1 second rapidly increases to 2054 kelvins, which indicates the beginning of the thermite void formation. The process of beginning thermites takes place at the temperature of 3200 kelvins, which exceeds the boiling point of iron. This in turn allows you to add to the charge of the metal fiber in such volume that the temperature of the melt to form a functional layer was not than 574 kelvins. It's 4 curve. It's the temperature. The increases in the temperature of the thermite alloy directly depends on both the preheating of the mold and the amount of the metal fiber in the thermite charge. Thus, the result of the process technology are obtained in samples of thermite alloy on the surface of which, when the mold is heated to 873 kelvin. In the slag phase, metal inclusions are formed a spherical shape slag. This is due to the rapid stage of combustion and accompanied by intense spraying in the resulting synthesis metal. The result of study of adding to thermite charge of 40% of the metal fiber are present in and fissure 2. Not heating, without heating, 473 kelvins, 673 kelvins, 873 kelvins, the best examples. When the thermite charge contains more than 40% of metal fiber, regardless of the heating temperature of the mold, there is a decrease in melt temperature which leads to the significant porosity as well as the presence of oxidized areas in the joint of the didn't melt it. Like this and this. In metallographic studies on the formation zone of the thermite alloy layer with the metal base at a heated temperature of the mold below 473 kelvins, there was a loose connection of layers with the base. There were inclusions in slag. In the upper part, there were shrinkage shells. For samples obtained by heating the mold of 873 kelvins, the liquid state of the thermite alloy was longer. The time to crystallization was 16 seconds. The surface of the metal base melted. And the slag, consisting of corundum, emerged from the zone of functional layer formation. Thus, the zone of formation of the functional layer is characterized by stability of the macrostructure and the positive effect of corundum, which creating the effect of inoculating modification for the thermite alloy. In turn, contributes to the formation of chromium carbides. The obtained samples were investigate to the such properties as density of gravity, porosity, and yield of alloy. It is shown that increasing of the amount of metal fiber in the charge from 80 to 40% when heating the mold to 873 Kelvin increases the yield of suitable thermite alloy to 74% by weight of the original charge, of course. It increases the density of 7.05 kg per meter cube and reduces the porosity of the formed thermite alloy to 5.5%. So, the technology of forming of thermite alloy layer on the basis of ferrum chrome carbon system on the metal by self-propagating high temperature synthesis process is offered, which allows to obtain cast functional layer with improved physical, mechanical and operational properties. It is shown that the increase in the amount of the metal filler from 20 to 40% in the mold, heated up to 873 Kelvin, affects the properties of the form layer of thermite alloy, increases the density of the alloy by 33% and decreases its porosity by 17%, while the yields of suitable thermite alloy increases to 74 absolute percent. It should be noted that lowering the heating temperature of the mold below 873 Kelvin degrades the quality of the formed thermite alloy layer, doesn't separate from the slag, and released into separate spherical formation. Metallographic studies of the optimal and obtaining war-resistant layer of thermite alloy shows that the zone of functional layer formation is characterized by macrostructure stability, positive effect of corundum. It is obtained alloy. In this case, non-metal inclusions in the form of corundum, creating the effect of inoculating modification for the thermite alloy, in turn contribute to the formation of chromium carbides. Thank you for attention.